All right, this is example 4, asynchronous work for pre-calc, and mainly for the regular students who were a little bit confused for chapter 5-1. And this is going to be good review from the upcoming quiz for pre-calc regular students. Okay, but if you're honor students, honor class, and if you want to review, please watch this one too. First, this was example 4 question, and in our class we did this one, and to use the Pythagorean identity to rewrite this one to 1 plus cotangent square x. And how can we? It's hard to believe these two equations, means two expressions are equivalent to each other, right? So in that case, I would do it right here. So cotangent square x can be written cosine square x over sine square x, right? I wonder if you remember that one of the identity. So this is one of the identities. So if you do this, this expression 1 can be written as sine square x over sine square x, which is still 1. Now you have common denominator now. So sine square x is a common denominator, and sine square x plus cosine square x is 1. Wait, something different. Yeah, this is it. So which means cosecant square x. Yeah, so this now it's equivalent. Yeah. So you can write down this expression into here. So these, let me see, maybe I can use next page. So since this right here and this equation right here, and let me erase this. So it's going to be quickly delete this. So now you notice this right here is equivalent to this. So let me highlight again. Right here is equivalent to this, right? So if you rewrite this one, this expression right here, you can rewrite this highlight section with lower highlighter. So it's 1 plus cotangent square x. Okay. So now collect like terms. It's going to be 1 minus 3 is negative 2. But let's leading coefficients called cotangent square x minus cotangent x, and 1 minus 3 is negative 2. So this is the expression. Yeah. Now, the goal in this class to factor this. So it's a little bit confusing to see cotangent expression here, right? So in our class, I will rewrite this expression right here, cotangent x, to big letter M, and rewrite the question. So if I write down this one, cotangent x represent cotangent x. If you represent cotangent x equal big capital letter M, you can rewrite this question to M squared and M minus 2, which is, you can factor this, you can use x factor, m minus 2, the difference is -1, right? And m minus m plus 1, so difference is -1, and multiplication is -2. Multiply those columns, -2. Now, you factor this. Now you can bring this one back here. Cosine x. So let me make sure you understand. Now you can bring this one back here. So this is going to be same expression. However, you have to rewrite m equal cosine x. I'm sorry, cotangent x. So it's going to be cotangent. So no more square sign, cotangent x and cotangent x. That's it. This was the example 4. Let me kind of backwards, but let's do example 3 too. I hope you understand this. So this is example 4. Okay, example 3. Example 3 was, where's example? Oh, example 3 was this. I think we did example 3 okay. Let's see. Let's do example 3 too. Example 3 was secant square minus 1. Let's see. So, okay, so this is what we did. So if the difference of two squares, so we rewrite this m plus 1 and m minus 1. And since this one's secant, m represent, as you see, is secant x. So secant theta, I'm sorry, secant theta plus 1 and secant theta minus 1. So let me write down. This might be easier for you to see this. So m represent represented secant theta. Secant theta. Okay. So you don't have to deal with some square mark here, right? So you just plug in here. So this is the equation. So let's take a look at letter B. Letter B was this. Oh, this is letter A. Sorry, we just did the same equation here. This represent. So I wrote down this. I use a capital letter X this time. Capital letter X equal to tangent theta. Okay, so if you rewrite tangent theta as x, the capital letter X, 4x squared plus x minus 3. So if you see this highlighter here, highlighter 4, and coefficient here is going to be 1, and constant is -3. So if you do the x factors, it's going to be 4 times -3 is 12, and the coefficient is 1, so you write down 1. What is a number if you multiply? It's going to be -12. If you multiply, if you add, it's going to be +1. The choice is -3 and +4. So if you type in +4 here, 4 square, because leading coefficient is 4, x and 4, and the variable is x. So 4x times 4x is supposed to be 16x squared. But you have to come up 4x squared. So one of them has to be, if you carry one number, it's going to be lowest term. So you have to factor it. So you plug in 4 here. So 4x plus 4 here, 4x minus 4 here. But its common factor is 4, so you change to 1. So 4x minus 3 and x plus 1. So let me write down that one. So this is supposed to be, for capital letter X and x capital like plus 1. Now you see how I did it, because you you cancel out here. So if you factor this, it's going to be, actually, you come back to this. Yeah, so I put the equal sign because this is equivalent to one equation above. Now, what we have to do here, you have to convert back to tangent theta. So tangent theta, x, capital letter X represent tangent theta. So 4 tangent theta minus 3 and tangent theta plus 1. Okay, this is the end of the video from we just did example 3 and 4. So if you have any question, get back to me. I will create example 5 and example 6. Okay.